Next, we're going to look at 3D Cartesian coordinate system. So here is how we can convert between Cartesian coordinates and spherical coordinates. So for example, if we have the distance from O to P, which is R here, and the angle theta, 3 value, we can calculate Cartesian coordinate, 3D Cartesian coordinates, which are x, y, and z. So in order to do that, we just use the following formulas, where we have x is equal to r multiplied by sine theta and multiplied by cosine of phi. So actually the way that we can calculate x is actually, the first is that we project OP on this plane, which is OXY plane. Then we have this distance from O to this point here, probably B prime. And then the second time we want to calculate x, we just project this distance into our x-axis. So if we already have this distance from O to P point, it becomes a 2D Cartesian coordinate system. So that's why we can have this x is equal to y sine theta and cosine phi. Similar, if we want to calculate y, we just project P on this plane, OXY plane. Then we project this point into our x-axis, y-axis, and we have this z is equal to r multiplied by sine of theta and multiplied by sine of phi. For the z value, is very straightforward. We just project p onto z-axis, and it's just equal to r and cosine of theta. That is from polar coordinate, 3D polar coordinate to 3D Cartesian coordinates. So what if we have the coordinate of P and we want to calculate R and we want to calculate theta and phi? It is also a similar way we can do is that so if we know the coordinate of P, which is x, y, and z, then we can calculate R using this formula, which is just a square root of sum of square of x and y and z. And for this angle phi, which is just the a sine of y over square root of x square and y square. Similar, we can calculate phi using this formula. So phi can be calculated using this formula or this formula. And then the theta as well. Theta can be calculated using z and r, or it can be also calculated using this formula. So there's a different way to convert from Cartesian coordinates in 3D to polar coordinates in 3D. So that's the theory of how to do it. Now we're going to try to do it in Python. It's also pretty simple. So for example, we have a point which has a coordinate of x is 2, y is 3, and z is 4. Then we can calculate r using this formula here, which is square root of x square and y square and z square. Then we can print the result of r. After that, we then calculate. So we then calculate the angle, which is theta. Theta is just calculated based on this formula, which is mass degrees of mass of a cos of z over r. Then we calculate phi, which is from this formula. Is that the z from that formula? So phi, actually the formula I use here is wrong. Okay, or it can be from r tan. So it's actually so it's from this formula, which is the phi is just y over x. It's very simple formula. And then we can have the value looks like this. So if x, y, z is two 3, 4. Then we have r is 5, which is makes sense. Then we have the theta, which is this angle, is 42, and phi here is 56. And that's it. That's the way that we convert Cartesian coordinate to polar coordinates. So similar, if we have polar coordinate, for example, r, phi, and theta, we can use these formulas to calculate x and y and z easily using Python.